I'm recording.
All right. Well, I'd like to welcome you today to our beef and forage focused webinars. This is a series of webinars that we held on the first and third Tuesdays of the month, and today I'm pleased to have Dr. Keith Bolsen with us. He's retired as professor from Kansas State University, focused a lot on silage research during his time there, and going to talk about some keys of harvesting and storage silage. Dr. Bolsen?
Thanks, Aaron. Good afternoon, everybody. It's a pleasure for me to participate in the webinar series and also to be working with Aaron Berger, who's a nephew of one of my grad students, Larry Berger, who everyone knows is Animal Science Department head now at Nebraska, and pretty proud of that. Actually, I was in that first wave of Nebraska feedlot PhD students back in that late 60, early 70 era, and graduated in June of 71 with a PhD under Walter Woods, and Terry Klopfenstein was on my committee, and I took a job at K-State and was going to do feedlot research, and Don Good, the department head, brought me into his office in October of 71 and said, "Keith, I need to put you in charge of the department's forage program." And I said, "Dr. Good, I don't know anything about silage," and I knew there were 14 silos at the new research farm, and you can see 10 of them in that first picture on the title slide on the left. And I told him I didn't know anything about silage. He said, "Well, Keith, you're a young man, you got plenty of time to learn." So 42 years later, I'm still learning, Aaron. So fine-tuning a silage program and saving someone's life, and would acknowledge my wife and partner, Ruthie Bolsen, who co-authored on this, and the Lord gave both of us a second chance 11 years ago, and we're really enjoying life. And gosh, we probably looked at more silage than any other two people on the planet in the last 10 years. So let's get started. The silage triangle. Back in 1971, there were very few silage contractors. We had a 2-row pull-type John Deere chopper at the Animal Science Research Farm when I got there, and now we have, 8, 10, 12-row choppers, and we're bringing in silage contractors, or we're buying crops from neighbors and growers, and so we like to refer to the silage triangle as the dairy or feedlot, the silage contractor, and the crop grower. And it creates opportunities, but it also creates challenges as far as communicating and getting everybody on the same page. And I acknowledge Sabina Schmidt, my grad student from Atwood, Kansas in the late 90s. She took the picture you see on that slide. That's David Briner of Mill Creek Hereford Ranch, August of 1999. David had been out of the silage business for about 15 years and was getting back into it. I was pretty nervous, and so we went to visit David the day that he started chopping corn. And what we're looking at here is David's silage contractor harvesting the last few acres of corn from a field that David brought from his neighbor. So we're looking at the 3 points of the silage triangle on that picture, and Tobin is the one that coined that term. Mentioned communication. Well, we'll get to that. Let's talk about shrink. I think the number one issue we're facing today in our silage industry is safety, and we'll conclude today with comments about safety. The number 2 issue in our silage industry today is shrink loss, or dry matter loss. Shrink is too high too often. And here's just 5 random photos of beef operations that have high shrink. So how much is shrink loss going to cost as far as corn silage that we're going to harvest in 2013 and get fed up sometime in 2014? How much are we going to lose to shrink? Well, we're going to lose about $1.3 billion worth of corn silage to shrink. I think it's possible to cut that number in half. I think it's possible to cut that dollar value in shrink in corn silage alone from $1.3 billion to $600 million. How do we get to $1.3 billion? Well, the last 5 years in the U.S., we've averaged 109.9 million tons of corn silage annually. Nebraska's averaged about, wrote that number down, about 3.5 million tons of corn silage annually in the last 5 years. Last year, Nebraska put up 4.4 million tons of corn silage. I think our average shrink loss across the board in the country in corn silage is about 18%. So if we put up 110 million last year, it's worth $60 a ton roughly. That's 7.1 billion. You lose 18% of that, $1.3 billion. There's a tremendous opportunity to reduce shrink loss in our silage programs. Okay? How does shrink impact the value of silage? Let's just take corn silage and say last fall, when all costs were in, a producer had invested $60 a ton in his corn silage. He had bought the crop, he had chopped it, he had inoculated it, sealed it, done everything right, hadn't fed a ton of it yet, he had invested $60. Divide that 60 by 0.9. In other words, lose 10%. So to cover your shrink, you divide the 60 by 90%, and so the true cost of feeding a ton of corn silage would be 66, 67. If you're losing 25% dry matter loss, shrink loss, you're dividing by 0.75. And that actual cost of feeding a ton of corn silage is $80. So if we're looking at cost of gain, your dairy looking at milk over feed costs, it's a big difference whether you're taking that corn silage value times $66 or $80. So, fine-tuning a silage program. I'm talking about 4 things: communication and prepare, density, sealing, and managing the delivery. Communication and preparing. Back to the silage triangle. You bring in growers that have an agenda, you bring in a silage contractor that has an agenda. And now we've got the dairy or feedlot or the beef operation. So communication and timing is absolutely everything. Get everybody on the same page. Have a team meeting. Have a bunker meeting. Have a meeting at the feed out face of the bunker pile. Have a meeting in the office. Have more than one meeting. I think the best time to have a meeting is a week or two after you've finished the silage season in the fall. Get everybody on your team together and talk about things that went well and things that didn't go so well and how we can improve. And Ruthie and I have helped facilitate and participated in literally dozens of silage team meetings since I retired in 2003. So communicate, prepare, and get on the same page. I like this slide. What can we learn from this producer? And there we see the producer below the red arrow. Well, this producer, and this happens to be a dairy producer in California, had a team meeting. We called it a tailgate meeting, and you can see the coffee jug there on the tailgate of the pickup. I've got 2 individuals circled in this picture. There were 2 silage contractors involved at this dairy, okay? And 2 key people in that team meeting were the primary blade push tractor operators for each silage contractor. And these gentlemen are circled, okay? We had truck drivers, we had chopper operators, we had employees of the dairy who actually do the feeding, we had the nutritionist, we had the company that covers the pile, but we got everybody on the same page and we had a meeting, okay? Well, density. Density is a huge issue in silage production and management and achieving a low shrink loss. As an academic community, we played catch up on density. We really didn't look at density as an academic community until the mid-1990s. I know on our silage program at K-State, and I tell people that I had the privilege of being the captain of the silage team for 32 years, and we ignored density until Kurt Ruppel's master's thesis that was published in 1995 from Cornell, and Kurt Ruppel looked at density and shrink and documented this inverse relationship. So as density, pounds of dry matter per cubic foot, goes up, dry matter loss is going to go down. Let's just take, I'll try the pointer the first time. Let's take a 12-pound density, okay? This table would show that equates to an 18% shrink. Let's increase that to 16 pounds of dry matter per cubic foot. That equates to a 14. Now, what's important about this table is not the true numbers, but the relationship. There are too many other interacting factors that affect dry matter loss and shrink besides density. So I can't say that at a 12-pound density, I'll have an 18% shrink. What I can say is that if I increase that density to 15, 16, or 17 pounds of dry matter per cubic foot, I'm going to reduce my dry matter loss by 4 to 6 percentage points. In other words, I'm going to be saving 80 to 120 pounds of silage as fed for every ton I ensile if I take that density up from 12 to 16. Something else that really got our attention was a survey out of Wisconsin, U.S. Dairy Forage, and 20 county agents in Wisconsin, and Brian Holmes in the Ag Engineer Department in 1997 looked at density on 168 farms in Wisconsin. These were bunker silos, alfalfa and corn primarily, and they recorded factors when those silages were being made. They went back and took core samples for density. And they documented that the average density was 14.5 pounds of dry matter per cubic foot. We haven't moved that number up much since 1997. I think our target density should be 16 pounds of dry matter, or about 48 pound fresh weight per cubic foot. Okay? But the important relationship is density and shrink loss. Well, let's look at a case study feedlot. This is a feedlot that we had the privilege of working with in 2006. We used the bunker density spreadsheets that are published by Holmes and Muck. You can look those up on Wisconsin Team Forage website. You can email Ruthie and I, and we'll get them to you. If you're at all involved with silage, you need to have these spreadsheets on your PC or your laptop. And if we just look at the factors that have influenced density, we've got the bunker wall height, we've got the height above the wall, we've got the delivery rate in tons per hour, and that's 135 tons, as you can see there. We'll try the pointer again. Dry matter content of the forage. So at a delivery rate of 135 tons an hour, one pack tractor, 55,000 pounds, on the forage 65% of the time, 9-inch layer thickness, which is circled. The Holmes Muck spreadsheet would predict a dry matter density of 11.2 pounds of dry matter, fresh weight density of 33.6. The average was 14.5. 15 years ago, our targets are 16 and 48. We're woefully short. We add a second pack tractor, okay? So we add a second tractor, 50,000 pounds. We drop the layer thickness from 9 to 5, and the spreadsheet predicts our density at 16, 9, and 50. But in this particular scenario, there were going to be 2 choppers, not one. The delivery rate was going to be 270 tons an hour. Now, if we've only got the one pack tractor, the spreadsheet would predict the density at under 10 pounds of dry matter per cubic foot, as we can see here, or 29 pounds fresh weight per cubic foot. The second tractor that we have on there now is going to have a density of just under 12 pounds of dry matter, 35.5 pounds per cubic foot. Again, well below the target. So what needs to be done in this situation? Add a third pack tractor, 45,000 pounds. You drop the layer thickness. We're at 15.6 and 46.8. The spreadsheets are horseshoes and hand grenades. They take the guesswork out of it. I think the number one thing producers need to do is work with their contractor and their team and predict ahead of time if you have enough packing pressure. Now, in this scenario, there was a third chopper part of the time. So, 3 tractors, the third chopper bringing now 400 tons an hour. And I don't show it on a slide, but at 400 tons an hour, 3 pack tractors in this scenario, the densities will be 12 pounds of dry matter and about 36 pound fresh weight. So we would be short with that third chopper, okay? So we have to be prepared, we have to be flexible as conditions change. But density, hugely important. Okay, take the guesswork out of it. Use the spreadsheets, predict it ahead of time. Okay, sealing. We did a survey in 1988-89 in Kansas with 25 county agents. It was not a survey where we could publish the results. We estimated that only about 15 to 18% of our 3 million tons of silage in Kansas that year was sealed, soft sheet of plastic. In other words, over 80% of our silage was not being covered. And I thought, wow, what's going on here? So I sent 2 graduate students to the library. They came back with 2 papers that showed what you lose if you don't seal a bunker or pile, or if you do seal it with plastic. Only 2 papers. One in 1956 in Australia, the other one from David Shingothi and Tom Olberg at South Dakota State in 1979. So, I think one of the research projects that I'm the most proud of at K-State during those 32 years was our work on sealing and covering bunkers and piles. Okay, here upper left you can see the 10 small bunkers that we built in April of 1989. We studied what happens in the top 4 feet in a bunker silo, whether it's covered, not covered, carried into the second year, different stages of maturity, different packing densities, and studied the factors that affect losses in the original outer 3 or 4 feet. Okay? This picture here was taken in March of 1990. The little bunker on the left was sealed with plastic and tires that touch. The bunker on the right was not sealed. The bunker on the right came up to the top of the back wall. 6 months later, where was it? It was 8 to 10 inches below the wall. The dry matter loss in the outer original 4 feet in the unsealed bunker on the right after 6 months was 65%. Bunker on the left that was sealed was 14%. Okay? Got a picture of a cattleman friend of mine, Richard Porter. Richard Porter is a farmer, rancher, cattle feeder, Redding, Kansas. Richard was a loyal supporter of our K-State sealing and surface spoilage research for about an 11 or 12-year period. At Cattleman's Day in 1997, one of my grad students was presenting a spreadsheet on what you gain or lose by sealing bunkers and piles. Richard said that after he sealed his first bunkers, his neighbors said, and I quote, "Porter, you're crazy for covering those silage pits." And Rich told his neighbors, "I can pay doctors and lawyers to cover my pits and make money." After packing density, effective sealing is the second most important thing we do as it affects dry matter loss or shrink loss in a bunker or pile. 2003, Ruthie and I got involved with an oxygen barrier film called Silostop that was manufactured in Italy. We did the original field testing on this oxygen barrier film. This photo just shows a surface under it. Here's a field trial out in California. That's Ruthie at a heifer ranch or Brownwood, Texas in the fall of 2003 at one of our field trials. Bottom left picture is at a feed yard in western Kansas near Garden City. It was our second field trial. This is high moisture corn. We put the oxygen barrier film on the 23rd of September. We compared that to the black on white plastic that the feed yard was using. 9 months later, they hit the section where the oxygen barrier film was. I pulled the samples, looked at the dry matter losses in the outer 18 inches. It was dramatic, the difference, the visual difference in surface losses under the seal after 9 months under the oxygen barrier film. At a feed yard at Dimmitt, Texas, in the fall of 2003, we did the same thing on corn silage. And here are just 2 photos I took on June 1st. The left, you can see my comb in the outer 6 inches, zip, zero, no visible surface spoilage. Under black on white plastic the feed yard had been using, you can see the visual discoloration and the spoilage in the outer 6 inches, okay? Lehman Kong at the University of Delaware has also worked with this oxygen barrier film. It's really exciting technology. So, just show you the results of the first 2 field trials on the film. Corn silage at the Dimmitt feedlot in the outer 0 to 36 inches. Compared to standard plastic, get my pointer here, compared to standard plastic that we can see here, the oxygen barrier film reduced the estimated organic matter or dry matter loss from about 35% to about 18% in the original outer 3 feet. In other words, about a 50% reduction. In the high moisture corn at Garden City, in the outer 18 inches, the oxygen barrier film reduced the organic matter loss from about 12.1% to about 6.7%. Again, about a 50% reduction in dry matter loss in the original outer 18 inches. So, what are the economics of sealing bunkers and piles? I'm just going to show you one example of a drive-over pile with a 12-foot apex, an 80-foot base. This pile is 400 feet long. I keep forgetting to get the pointer. Aaron and Emily. Here we go. So, here's our apex height. There's our base. We've got a 1 to 3 slope on each side, which is criteria for a drive-over pile. Depending on the density, there's going to be between 4,000 and 4,600 tons of corn silage in this pile. Okay? Corn silage at $60 a ton. Let's look at sealing treatments. Standard black on white polyethylene. It's going to cost me about $5,000 in labor and materials to seal the pile. So standard plastic. With the oxygen barrier film, which is a 2-step process, the film is orange. You protect it from UV light with black on white plastic. The sealing cost will be about $7,800, okay? If you cut the loss in the outer 3 feet by 50%, the net benefit to the oxygen barrier film is somewhere between $8,000 and $12,000. So, sealing and sealing with oxygen barrier film are the most important silage management decisions that we're going to make this year. I'm going to take you to a feedlot somewhere in the high plains, okay? And we can see this earth-berm trench silo. It's got a dimension of 75 feet wide. I see a typo there. That should be 75 times 750. I don't know where that 60 came from. So we will correct this and delete that 60 there. So this trench is 16 feet deep, average depth, 75 foot width, 750 feet long. With an average density, there's 21,000 tons of corn silage in this feedlot's trench silo when it's filled. Okay? Here's the feeding face from this trench silo. We can go to this feedlot on MapQuest or Google Earth. I didn't go to this particular feedlot to protect its identity. I went to another feedlot, but on the feedlot in question, there were 4 trench silos like this one. Okay? And so I'm going to show a Google Earth from another feedlot that has 4 trench silos. 1, 2, 3, 4. Okay? And the average length of these, 750 feet. Average depth, 16 feet, like this feedlot in question, at $60 a ton. Now, in the outer 3 feet, this feedlot is not sealing these 3 trenches of corn silage. Okay? They are losing 2,100 tons. Poof, gone, because it's not sealed. If they seal it with black on white plastic, they lose 875 tons in the original outer 3 feet. It's going to cost about $10,500 to seal with 1 sheet of black on white polyethylene. The net silage saved by sealing would be $64,000 per bunker silo. There are 3 bunkers at this feedlot. That's $192,000 worth of corn silage inventory they could save by sealing. I've driven past this feed yard the last 10 years. They're not sealing. They're losing $190,000 worth of feed inventory that could be prevented. Okay. Manage the delivery. Very important. Silage is perishable, particularly corn silage. Oftentimes, we don't do a good job on presentation. So, let me just give you an example of the feedlot we worked with. How many times does their corn silage get exposed to oxygen during feed out before it gets to the feed bunk? Well, let's count them. Here the silage is at the feeding face. It hasn't been removed. Air penetrates 3 feet. So it's exposed to oxygen while it's still in the bunker at this point. It's loose on the floor of the bunker. That's the second time. Third time is in the bucket of the payloader. Fourth time is in this pile near the feed mill. Fifth time is in the conveyor at the feed mill. And again, I keep forgetting my pointer. Okay, so the fifth time would be in this conveyor. The sixth time would be in the ration in the feed truck. And finally, the seventh time this corn silage is exposed to oxygen is when it's delivered into the feed bunk. So from 1 to 6. And I say we can do better as an industry. As cattle feeders, we can do better. We got to minimize the time from the initial exposure to oxygen here and when the silage ration gets put in the bunk here. Okay? Surface spoilage research at K-State. Really excited about this work. From the original bunkers where we showed losses by sealing and not sealing, this work documents what happens if you feed the visible surface spoilage. This is Lance Whitlock's Masters. We put 3 feet of corn silage in our small bunkers, packed it to 44 pounds per cubic foot fresh weight, went off and left it 3 months, came back and sealed it. Lance didn't have 3 feet after 3 months of exposure. He had 22 inches. The top 14 inches of corn silage disappeared. Again, I'm looking for my pointer. Here we go. So we started with 3 feet, 3 months exposure unsealed, we lost 14 inches. It condensed into this 7-inch slime layer and a 15-inch wet acetic acid layer below it. Lance fed this visible slime layer at 4 levels to feedlot steers, 7-weight steers, diaper bags, total collection, 0, 5.4, 10.7, and 16% of this visible slime spoilage. What happened when Lance fed the slime? 3 things. Dry matter intake went down, the forage mat started to disappear, and fiber digestibility decreased dramatically. Let's just look at NDF digestibility, which is a very important component. It wasn't a linear effect. No slime spoilage to the high level. If it was linear, these 2 intermediate levels should fall on the red line. They didn't. They were below the line. That's the bad news. The surface spoilage does more damage nutritionally than we would predict. So how much is this Western Kansas farmer feeder grower losing because he's creating surface spoilage in his earthworm bunker of corn silage and then compounding the problem and feeding the spoilage? 2,500-ton bunker, growing fat grounding ration, late fall, early 2000s. How much is creating and feeding the surface spoilage costing this Western Kansas producer? Well, and this is in a national publication in the last 2 months. I took Lance's data, okay, for intake and digestibility. And I said, all right, we can interpolate, and if we just fed half of Lance's lowest level, in other words, 2.7% of that visible top layer of spoilage gets into the ration, okay? What's its effect going to be? NEG, no spoilage in the ration. I'm going to set the NEG at 0.45. 2.7, I'm going to leave the NEG at 0.45. I'm going to reduce intake. Half of the level of Lance's intake was reduced. So intake is going to go from 17 pounds of dry matter to 16.5. I'm going to leave dry matter recovery, preservation efficiency the same. In this scenario, our gain is going to go down. Our feed conversion is going to go from 7.55 to 7.8. Our gain per ton of crop and sile is going to go from 88 to 85. At $1.40 a pound, that's $3.92 lost live weight gain for every ton in sile because the bunker's not sealed and they're feeding the surface spoilage. Scenario 2, I'm going to drop the NEG. Okay? I'm going to drop the dry matter recovery because it wasn't sealed. I'm going to let intake the same. Look what happens to lost gain per ton. Goes from almost $4 to over $16. Then in a worst case scenario, higher dry matter loss, lower NEG, we're losing almost $30 per ton. Surface spoilage, got to prevent it. and it can be prevented. Seal it and use the option barrier film. Number one problem, wrapping up, in our silage industry today, and it's the one that frustrates Ruthie and I the most, is safety. Dennis Murphy said it best. We have nothing to lose by practicing safety. We have everything to lose by not practicing it. And I want to document that for you. So this scenario here, this young man standing here. Don't do something stupid. Here's a payloader shaving across the face, and here's the collapsed silage that's engulfed the payloader. How many feedlots and dairies have had a collapse on the payloader? How many have had an employee trapped in the payloader? In this situation, the employee escaped with just minor injuries. How many times have we walked up to a feeding face like this to pull a sample or to take a look? How many times have we done this? Gotten in a payloader bucket, had the operator raise us up so we could pull samples or take 4 samples for density. Don't do something stupid. Silage collapses. Avalanches happen. And if you don't believe it, just ask this young man right here, Doug DeGroff, dairy nutritionist, Visalia, California. Here's an article in the February 2010 Hay and Forage Grower written by Faye O'Lean, Surviving a Silage Avalanche. Doug DeGroff was engulfed in an avalanche from this feeding face right here. He photographs the feeding faces that he pulls samples from. Doug had pulled his sample, he was standing over here, mixing the sample, and suddenly it got totally dark, and he was engulfed in the avalanche. His left arm was free, he started pushing, and his arm pushed out through the surface. He was able to uncover his nose, and Doug DeGroff survived the avalanches. A lot of people have not been as fortunate as Doug DeGroff. Avalanches can and do happen. Ruthie found this on MSN homepage. We accessed this in August of 2010. WMUR-TV, Claremont, New Hampshire. Headline, boy buried in feed pile dies. Boy buried in pile of feed for up to 20 minutes. On this large dairy, Claremont, New Hampshire, young man on spring break, April 2010, riding his bike on the dairy where his father worked. Here's the silage face right here. Here's the top of the payloader, so this bunker's overfilled, probably a 25-foot face. And this young lad was engulfed in the avalanche, and he died 2 days later. These accidents are preventable. Take-home message, it's a stern one. It's really not about shrink loss or dry matter loss or feed conversion or cost of gain or closeouts or milk over feed. It's about sending everyone in your silage program home to their family safe every day. Let's start taking a serious look at silage safety. Let's start taking a serious look at not overfilling bunkers and piles. Let's start taking a serious look at not putting one of our employees in harm's way. Let's not have a tragedy. These can be prevented. Well, 33 minutes. Ruthie and I want to thank Aaron Berger and the Nebraska Beef Extension Service for inviting us to give this presentation today. Take-home message, have a team meeting, and let's have a safe and efficient silage program in 2013-2014. Thank you very much.
All right, thank you, Dr. Bolsen. Any questions before we wrap up today? If you have any questions, you can go ahead and type those in the chat box. While we're waiting for some questions, if they should come in, I just want to remind you that this webinar that's been recorded today will be available at the beef.unl.edu website. Also want to let you know that coming up in August, we'll have a couple more series on webinars there related to silage, pricing, and nutrition, and also using elevated silage and finishing diets. Dr. Galen Erickson will present both those webinars. The first one will be on Tuesday, August the 13th, and the second on Tuesday, August the 20th. Both will start at 12:30 Central Time.